Hi everyone, so today we're gonna learn about elementary row operation from matrices. Okay, let's get started. Okay, table of content of this lesson is we got introduction, problem statement, problem solution, conclusion and references. Okay, this is the introduction for elementary row operation. What is ERO or elementary row operation? It is the elementary operation of a matrix, also known as elementary transformation, are the operation performed on rows and columns of a matrix to transform the given matrix into a different form in order to make the calculation simpler. And why do we use ERO? Elementary operation or ERO are used in Gaussian elimination in order to transform the given matrix into the reduced row echelon form, or we call as REM and RREM. Okay, there are three cases of ERO. The case 1 is interchange of any two rows or two columns. Case 2 is multiplication of row or column by a non-zero number. And case 3 is multiplication of row or column by a non-zero number and add the result to the other row or column. Okay, let's see some example of the both three cases. Okay, case 1, interchange of any two rows or two columns. You can see here that this is a 3 times 3 matrix. And the case 1 is we swap row 2 with row 3. You can see here 4, 5, 6, 7, 8, 9, and we swap them. So the 7, 8, 9 will become row 2 and 4, 5, 6 will become row 3. Okay. And for case 2 is multiplication of row or column by a non-zero number. So here I choose row 2 and I multiply with negative 2. So 4 times negative 2 is negative 8. 5 times negative 2 is negative 10, and 6 times negative 2 is negative 12. For other row, you can just copy it back here. You can see here 1, 2, 3, 7, 8, 9, just like the old one. Okay, for case 3 is multiplication of row or column by a non-zero number and add the result to the other row or column. You can see here my condition for case 3 is 2 times with row 2 and plus with row 1. So 4 times 2, it will become 8, and 8 plus row 1, which is 1, and we get 9 here, okay? And 5 times row 2, 5 from row 2 times with 2, we get 10, and plus with row 1, which is 2, and we get 12 here, okay? And 6 times 2, we get 12, and plus row 1, which is 3, and we get 15. And other else, you just can copy it back, okay? Okay, now we go dive into the question of types of ERO equation. You have two types of ERO equation, which is row echelon matrices, REM, and row reduced echelon matrices, RREM. Okay, there are 4 properties that we need to follow to solve the question for REM. First, consists at least a non-zero row, not a zero matrix. The second one is the leftmost non-zero entries in every row is 1. We call this the leading one. Third one is the leading one in the lower row occurs farther to the right than the leading one in the upper row. For the last one is if there are any rows that consist entirely all zeros, then they are grouped together at the bottom of the matrix. Okay, now let's see some examples. Okay, first one is consists at least a non-zero row. That means the matrix cannot be all zero. It need at least have one number which is not zero, any number other than zeros. That's the first properties that we need to follow. And the second property said that the leftmost non-zero entries in every row is 1. We call this the leading one. As we can see here, as you can see the tick one, the number 1 need to be like stairs like this in order to follow these properties, and it cannot be like this. Okay. Okay, and the leading one in the lower row occurs farther to the right than the leading one in the upper row. It means that it has to be like 1 here, and it need to be right. The one need to be right. Okay, so it must be here, and it also need to be right again. So it be here. It cannot be 1 here, and then this one, we got no 1 at the right, so it is wrong. Okay, if there are any rows that consist entirely of zeros, then they are grouped together at the bottom of the matrix. Okay, we can see here that all zeros are from row 2, and we got row 3 here. So it cannot be like this. So all the zeros row need to be the bottom one, like this, at the row 3. Okay, now we jump into row reduced echelon matrices, or we call as RREM. For RREM, we need to follow all the REM properties and add one more properties, which is each column that contains a leading one has 0 everywhere else. Okay, it's mean like this. If you see here, 1, the below one and the upper one need to be zeros. So that the condition that we need to follow. Okay, and this one is wrong because you see here the upper from 1 is 2 and here is 1. Okay, and it also not follow the REM properties that we have learned just now.
Now,
Okay.
we can go through to the example of questions for ERO, Elementary Row Operation. For the first one, example 1 is row echelon matrix. So given matrix A is 2, 3, 4, 4, 6, 8, and 1, 3, 2. The question asks we to transfer matrix A into row echelon matrix REM. So the first we need to know is step by step to change the matrix into REM. So as we can look at the note, the first step we must make the first row and the first column in the left to become 1. So as we look, the value is 2. So what do we need to do is we must change the value 2 into 1. So if we want to change the value of 2, we also need to change all the same row. So as we can look, R1 is equal to R1 minus R3. When we minus R1 minus R3, we got the answer is 102. Okay, next. Okay, as we can look, the next step, the value of 1 in the left and in the left and the first row, we must change the value below that 1 to become 0. So we can look to become value under 1 is 4 and 1. So we need to change 4 and 1 into 0. So okay, R2 equals to R2 minus 4R3. When we minus, we can get the second row is 0, negative 6, and 0. Now for the third also we need to do the same thing by R3 minus R1 to become the 0. So when we get the value of 100 in the first column, okay, next we must apply the first step to the leftmost non-zero entry for the second row. So we must change the second value for 1 in the middle to become 1. So what do we need to do in the equation is we just need to multiply by negative 1 over 6. So we get 102, 010, and 030. So okay, next the last step is we must change entry the below the leading one in the column to 0. So we change, so we get 0, 0, 0, 0, 0, 0. So the value follow the 102, 010, and 000 following the REM requirement.
Okay, for the next example of row reduced echelon matrices, RREM, consider this matrix A, which is a 4 by 4 matrix with 2, negative 2, 4, and negative 2 as the first row, 2, 1, 10, and 7 as the second row, negative 4, 4, negative 8, and 4 as the third row, and the fourth row will be 4, negative 1, 14, and 6. Okay, so how can we change it into a row reduced echelon matrices? First, subtract the first row from the second row. So we got the second row, we subtract it with the first row, so we get 0 under the 2. Then add the third row with the first row multiplied by 2. So the first row, we multiply it by 2, and then we add to the third row. So we can get the third 0 under the 2. Next, subtract 2 times the first row from the fourth row. So times the first row by 2, and then subtract it to the fourth row. So we get 0. So now we got 30 under in column 1 under the 2. Then subtract second row from the fourth row. So the second row, we subtract it to the fourth row. So we can get most of the bottom part to be 0. Okay, but as you can see, we got 1 here. So we need to take this one and put it above. So we just swap the third row and the fourth row. So swap it, and then we get a nice staircase shape here, but it haven't satisfied the condition of a row echelon matrices, which need 1 here above the staircase as the pivot. So divide the first row with 2. So we got 1 here, and then we need to change the 3 into 1. So we will divide the second row with 3. So now we satisfy the condition for REM. Okay, and we got row echelon matrices now with all 0 under the pivot, which is 1. This is the pivot. But row reduced echelon matrices need zeros above the ones as well. So we need to change this -1 and this 3 and -1 into zeros. So what can we do? Okay, add row 3 from row 1. So this row 1 we add with row 3. So 1 plus -1, so we got 0. So now we got 0 for row 1. But next we need 0 for the second row as well. So times 3 for the third row, and then subtract it with row 1. So 1 times 3 is 3. So subtract it with 3, we got 0. So here we got 0. Now to eliminate this -1, we add second row to the first row. So 1 plus -1 equals to 0. So now we satisfy all conditions for a row reduced echelon matrices. Each column that contains a leading 1, the pivot, has 0 everywhere else in the column. So here is 1, we got 0, 1, 0, 0, 0, and then here 1, 0, 0, 0 with a nice staircase shape of zeros.
We need to find RREM. So for RREM solution, we need to make sure that the first leftmost non-zero entry at first row and first column need to be 1. So row 1 need to divide by 4, so we get this answer. So this is the case which the answer is in fraction that we can avoid. So for RREM, we need to make sure that this become 1, 1, 1, 0, 0, 0, 0. So we continue that to subtract row 1 multiplied by 4 from R2, from row 2, which is we can come up with this equation. So for this is the one that we need to change the row. So we need to put here and subtract with 4 that multiply by R1. With row 3 we need to change. So row 3 we need to get this into 0 and this one as possible. So subtract row 1 multiplied by 4 from row 3. So we get this answer. So we can see here at row 2 and row 2 column 2, which is equal to 0. So we need to swap this row 2 with row 3. So we can get 1, -1 here. So 0, 0. So we get into this answer. After we swap R2 with R3, so R2 multiply with -1. So we need to make sure that this row 2 become a positive number. So then we subtract row 2 multiplied by 5/4 from row 1. So we need to make this into a non-fraction number. So we get this answer. So this is the fraction that left. For row 3, we need to change this into 1. So R3 divide by 3, so we get this answer. So we get 0, 0, 1, 6, -6. So then this number is a fraction number. So we need to subtract row 3 multiply by 1/2 from row 1. So we get this answer, 0, 1, 0, 0, -3, -10. So this is the final answer. So we get 1, 0, 0, 0, 1, 0, 0, 0, 1 for this red color, which is satisfy the option that each column that contain a leading 1 has 0 everywhere else. So leading 1 have 0, leading 1 have 0, leading 1 have 0. So it is also RAM because it's a leading 1 like this. So that's all. Thank you.